Welcome back, students. Mr. McCoy here. Today we are continuing our discussion of loops with learning about something called accumulation. So obviously accumulation sounds like a vocab word you might need to know. Think about what it means in the English language. A collector's job is to accumulate things, sometimes junk, but yeah, it's about gathering things up, and so it could be used in programming as well if we want to gather things, usually during a loop. But while some collectors might accumulate things like Nintendo Amiibos, in Java programming we tend to accumulate values into variables. Keep in mind, variables are designed to have their value changed. So let's say you want to add up all of the numbers from 1 to some other number, and let's just call that number n. N might be 5, it might be 10, it might be 632. We want to add up all the numbers from 1 to that other number. So we could do this manually. We could say 1 plus 2 plus 3 plus 4 plus 5 all the way up to 632. That sounds like a nightmare. That could take a long time to do that. But with a loop, that process would be very easy. So before we talk about how we would do that process, let me throw a couple other vocab words at you. First off, pseudocode. Pseudocode means false code, and so this right here would be an example of pseudocode. We've written out in the English language the algorithm that we're going to turn into code later on. So this looks kind of like code, but the computer doesn't understand it. It's more written to be read by humans, but it lets us plan for what code we're going to write. So as our programs get more complicated, we're going to have to start writing pseudocode, English language versions of our program, so that we can map out the logic before we actually start coding. The other vocab word I want to talk about is iterate. We learned about loops already, and notice how with a loop you would run through it once, and then you go back up to the top, and you'd run through it again, and go back up to the top, and run through it again, back to the top. Each time you go through a loop is called an iteration. So to iterate through the loop would mean to run it multiple times. Alright, so let's talk about that algorithm for how do we add up all the numbers from 1 to n. How could we do that using a loop rather than just manually adding all the different numbers? Well, think about what variables you might need. First off, just to generate a loop, you're going to need some kind of loop variable, just so you have a starting point and you can test if it's reached its end point. But then also, you're trying to add up all those numbers, so it might be helpful to have a variable called sum that you're going to use to store your answer into. It's going to be the variable that accumulates or adds on additional values as we go. So let's make a new variable called sum, and let's start it at 0 because we haven't started adding anything into it yet. Then we could set up a loop that would look at all the numbers from 1 to n. So if our number is 632, then we want this loop to run 632 times, where our looping variable starts with a 1 and it keeps going, and then when our looping variable hits 632, then the loop would stop. Similar to what you did in the last set of labs. So if we're on the first time that we go through this loop, our current number is 1, and we'll increase sum by 1, and then we add 1 to that loop variable and it becomes 2, and then we increase sum by 2, and then we add 1 and it becomes 3, so then we increase sum by 3. You can see the pattern. It would keep going until we got to 632, and then it would be done. So what does that look like in real code? We have our sum variable set to equal. We have a loop variable I set to 1, and we want to run this while loop as long as our loop variable is less than n, or 632, whatever number is our maximum value. And each time we run through this, for each iteration of this while loop, we're going to increase the amount of sum, the value in sum, by I. So I'd probably prefer that people use this handy special assignment operator, but this does the same thing. And then we increase the value of I, and we continue the loop until we've reached our n. Once I becomes larger than n, this is going to exit the while loop and we'll be done. Sum will have then had an opportunity to add on every value from 1 to n. Let me walk you through the tracing of it. So we have variables sum and I, just like we did in our pseudocode, but we also have this variable n, and we're assuming that we have a value for n. Maybe earlier in our program we asked the user to supply a value for n. So I'm going to add another line of code in here just so that n has a value. Int n equals, let's just say 3, just to make it easy on us. So our goal is to add up all of the numbers from 1 to 3. I could have picked a much higher number than 3, but I didn't want this example to take too long. And we're going to trace through it, all the different steps that happens. So when I say trace, I mean we're keeping track of the individual variables. So I have sum, I have I, and I have this other variable n, which n isn't going to change. N is set to 3. That's the maximum value that we're trying to add up to. I starts off as 1, and sum starts off as 0. Okay, so let's run through this while loop. While I is less than or equal to n, is that true? 1 is less than or equal to 3. Yes, this is true, so we are going to run this loop. Sum equals sum plus I. So sum is 0, and it's now going to be equal to sum plus I. 0 plus 1. So 0 plus 1 is 1. So our new value of sum is 1. And then we need to increment I. So I becomes 2. We've reached the end of our while loop, so now we jump back up here. While I is less than or equal to n, is that still true? 2 is less than or equal to 3. Yes, so let's go inside again and put my check mark. Yes, that was true. Sum equals sum plus I. So now sum is 1, sum plus I, 1 plus 2, and our new value for sum is 3. Then I increments. I becomes 3. We've reached the end of our loop. Let's go back up and see if we need to do it again. Is I less than or equal to n? 3 is less than or equal to 3. Yes. So we go inside. Sum equals sum plus I. So sum is going to be 3 plus 3, or in other words 6. And I increments again to 4. We've reached the end of our loop. Go back up and check it. While I is less than or equal to n, 4 is not less than or equal to 3, so it will not run a fourth time, and now execution of code jumps back down here, and we start working below that. It doesn't run this a fourth time. So the value of sum is 6. So what did that tell us? Some of the numbers from 1 to 3 added up to 6. 1 plus 2 plus 3 equals 6. So it accumulated all of those numbers into the value of 6, and so you can see how if you changed this, instead of 3, you're at 632, then you would find out whenever this loop was done, you would find out 1 plus 2 plus 3 plus 4 all the way to 632. That would be what's stored inside of sum. But you didn't have to do it manually, you just let the loop do it. And today I also want to throw another piece of vocab at you. Let's talk about Sentinel controlled loops. As a quick review, you know what nesting means, right? We did that with nested ifs back in lesson 9, I believe. That refers to placing something inside of something else. So if we have some curly brackets and inside of those curly brackets we put something else that has curly brackets, then we're nesting. So check this one out. Here we have a while loop, and inside of the curly brackets we have an if statement that has curly brackets. So we have a nested if inside of our while. Let's think about what's happening in this example. I is 0, count is 0, while I is less than 5. And somewhere inside of our while loop we increment I by 1 each time, so we know this loop is going to run 5 times. And each time it runs we check to see if I is equal to 2. If I is equal to 2, then our value of count increases, and whenever the loop is done, we're printing the value of count. So what does this do? Kind of a weird program, but it looks at all the numbers from 0 to 5, and it asks how many 2's there are in that range between 0 and 5, and obviously there's 1, so count increased only once. So a very weird example, but we just wanted to show you how you could nest ifs inside of whiles. Alright, so what is a sentinel? What is the point of this set of notes? Well, a sentinel is a person or thing that watches. That's it. It just watches. So in computer science, a sentinel would be a variable, but a sentinel-controlled loop would be, maybe there's a variable that watches to see when that loop should stop running. So in all of our previous versions of loops, we had a definite endpoint. The loop was going to iterate from one point to another, and you knew exactly how many times that loop was going to run. With a sentinel, you don't necessarily know how many times the loop is going to run, but the sentinel is going to let you know whenever it should stop running. Here's an example of that idea. So we have our keyboard. You usually see that as console. Maybe I should change that to console. Scanner console and then console.nextInt. You're big kids, you can figure this out. Here, rather than calling it console, we call it keyboard. So this program asks you to enter a number, and so the user provides a number, and we're storing that in num. Then we run into a loop, and we say, while num is not equal to -1, get another number. So let me trace through this real fast. Alright, so we've got a variable called num, and they ask us to put in a number. So let's just put in a number 2. While num does not equal -1. Well, that doesn't equal -1, so this is a true statement. So let's go in here. We're going to print enter again and ask them to supply a new value for num. So what do we want to change num to? We can type in any number that we want. Let's change it to 4. End of our loop, so let's go back up. Is num not equal to -1? Yeah, it's not equal to -1, so this is true again. Let's ask them to enter another number, maybe this time 7. Loops up again. So it's not equal to -1, that's true. And this time they ask enter again. I'm going to type in a -1 this time. It goes back up here, while num is not equal to -1. Well, it is equal to -1, so now this is a false statement, and we're done. So notice how we had no idea how many times this loop was going to run. It kept running until the user typed in a -1. So this is what's called a sentinel controlled loop. You didn't know how many times it would run. There was a sentinel. In this case, the sentinel was num, and whenever num became a particular value, we stopped running the loop. Think about how this could be beneficial. If you created a game, if you want that code to run repeatedly until the user says, hey, I don't want to do this anymore, that would be a sentinel controlled loop. You allow the user to run that code over and over again until the user requests a stop. Now your sentinel doesn't have to be a number. Your sentinel could be a boolean. So here's another example where we're asking the user to type in numbers, and we're checking to see, we're going to keep running this loop until we encounter an even. So we have this variable called foundInEven, and we set it equal to false. We have another variable I, and it is equal to 3. Now, while foundInEven is false, it is false, so we're going to run this while loop. If I mod 2 equals 0, so remember this is how we check to see if something is even, because an even number mod 2 is going to give us no remainder. So if I is even, then we will set foundInEven to true. So this is a flag where this foundInEven becomes true as soon as I is even, but I isn't even, so this stuff doesn't run. Down here we haven't provided any code, but let's say there is some code where the I value changes. Say the I value becomes 5. Then we jump back up here. FoundInEven is still false, so this is going to run again. If I mod 2 is 0. It's not. So we skip that part, go down here, we change the value of I again. Let's say this time it is 18. Go back up, found and even is false, yes. So we go inside, if I mod 2 is 0. Well, I is 18, 18 mod 2 is 0, so finally this is true. Found and even becomes true now. We've reached the end of our loop and we go back up. While found and even is false. Nope, it's true now, so this doesn't run. So we continue execution of our code. Alright, well let's take a look at the labs now. Alright, so I've got the labs document open, ready to go. New BlueJ project with practice problems and guessing game. Let's do our first practice problem. Prompt the user, asking them to enter an integer n. Write the code to print out all the numbers from 1 to n. So this isn't much different than what we did last time, except that now I need to get something from the user. Let me provide a prompt. Enter an integer. And we're going to store that in n. And just for the sake of good practice, I'm going to clear the console's keyboard buffer using just a lone line command. Alright, so we got a value for n, and we just need to print to the screen all the numbers from 1 to n. So we need a looping variable, int I. I want to start from 1, and I want my loop to run while I is less than or equal to n. There's usually some question, do you want less than, or do you want less than or equals to? If I do less than n, then it'll print 1 up until n, but not including n. But if I actually want n to be printed also, then I should include the equals. So while I is less than or equal to n, what do I want to do? I just want to print something. System.out.print I. I is the value that's going to be changing. Print I, and then increment I so that whenever we run this while loop again, I will have a different value. And maybe I want it to be formatted a little bit better. Let's go ahead and take a look at what we have now. Forgot a semicolon. Yep, even teachers do that. Enter an integer. Oh man, I kind of want that to be printed up there, so that shouldn't be a print line. Alright, my integer 5. So 1, 2, 3, 4, 5. Maybe I want there to be spaces between them, so after I print I, let's concatenate on a space. I think that would look nicer. Compile, run. Alright, let's go with 23. So there's all the numbers from 1 to 23. Very similar to what you did last time, except now we're getting some user input. Number 2 changes it up a bit though. Now we're going to bring in some accumulation. Get a new value in from the keyboard. Write the code to sum up all the numbers from 1 to n. Alright, so this is going to be similar to this. Enter an integer, and I can't redeclare n, but I can use it again. So take out the declaration. Enter an integer, they're going to store a new value into n, and now I need to accumulate. So I need an accumulation variable. Let's have one called sum, and let's start that at 0. And then I want to have code similar to this loop. I have my looping variable I, and I want to run this while I is less than n. But inside of my loop, rather than printing I to the screen, I want to accumulate all the values of I. I want my sum variable to increase by I. You could write that as sum equals sum plus I, or sum plus equals I. Then I increases, and we repeat the process. Eventually we hit n, and that's the last step of that loop. And as soon as the loop is done, then we want to print a statement saying the sum of all numbers from 1 to whatever we put in Oh, I did a bad prompt. The prompt should look like this. Enter an integer from 1 to 1000. Enter an integer from 1 to 1000. Then if you wanted, you could do some if statements in here to ensure that the number they typed in was in fact from 1 to 1000. Give an error message if they typed in a bad number maybe. Alright, so after you've done your accumulation and you've added all that up and stored the answer into sum, then we need to print a message that looks like this. So our output is going to be sum of all numbers from 1 to, well, and I don't want to type 250 right there because that might be, the user might not type 250, so I want to actually concatenate in my value of n. That's what they provided. Expand this so you can see it. And then sum. So I've got 4 pieces of my concatenation puzzle here. My header, sum of all numbers from 1 to, and then it's going to replace n with whatever we typed in. Got our output arrows here, and then our final answer of sum. So let's check it out. Compile. Of course we have an error. Oh, I can't redeclare I because I declared I up here, so I cannot do that. But we don't want to declare I as a new variable, we just want to set its value back to 1. Compile. It's good. Enter an integer, 23. Okay. Well, I don't like it being on the same line, so let me go up here and after this one's done, system.out.println, and let's print the new line character, so that'll do a couple lines. Okay, let's run our new one. Enter an integer 23. Okay, now we go down a couple lines. Enter an integer from 1 to 1000. The example in the Word doc is 250, so let me type in 250. And we got the correct answer, 31,375. Now let me try that again with a different value. Let's do 15 here. Let's add up all the integers from 1 to 10. You can see it adjusted the statement correctly. The sum of all numbers from 1 to 10, not 250, and it gave us the correct sum. This is a smaller number, so I could work this out by hand to ensure that it's accurate. Alright, so what else is coming up in this lab? There's a guessing game app. In this game, the computer picks a random number between 1 and 1000, and your job is to guess what number it chose. This is actually way more complicated than anything you've done before. You're finally making a Java game. So the computer has a random number. You try to guess that number, and if you guessed incorrectly, then the computer gives you a hint. The computer will tell you that maybe you guessed too low, or maybe you guessed too high, and then you can refine your choice. Now you have a set number of guesses. You're only allowed to guess 7 times. And if you guess more than 7 times, then your program should say game over, you lose, and tell you what the correct number is. Or your program should also end if you got the number correct. So if you had a lucky guess on your 3rd attempt and you got it correct, then your game would end. It's certainly a good idea that you pseudocode. So there's a note in here about how you should pseudocode this out. Remember, pseudocode means false code, and that's where you write out an English version of the logical steps that your program needs to take. You might grab a sheet of paper and work that out, or type it up on the computer, just step by step. What does your program need to do? And you need to feel confident that it's going to work before you try to turn it into code. It's going to be pretty complicated. Now, frequently, whenever you're writing a program of this complexity, you'll finish writing your code and then realize that you have a logical flaw, and even though your program runs, it doesn't run correctly, and you're trying to figure out why doesn't it run correctly. Well, you're going to want to use those tracing methods that I talked about in the previous lab, where you set a breakpoint and then you run your code, and whenever your code gets to that spot, it stops execution and brings up a debugger. And in the debugger, you can use the step into block to run it line by line. So notice how as I click step into, it's showing exactly how my code is executing. And I can take a look at the variables. I can see that n is 20. That's the number that I typed in right there, 20. I can see that I is 6, so I'm currently on my 6th iteration of this loop since I started at 1, and it's increasing by 1 each time. You can see the I increase as you go. You can also see sum increasing by I each time. So sum is 28, and whenever I becomes 8, then this goes up by 8, so up to 36. So you can see those variables changing as you click through your program line by line. That might be something you need to do in order to debug and find your logic errors inside of your programs. Alright, so good luck on the labs.
Enjoying my class? Smash that like button. Don't forget to subscribe and follow me on TwitFace. But hey, that's just a tutorial. A computer science tutorial. Thanks for watching.